Hello everyone and welcome to Power Playground. This is your host Michael, and today I'm going to show you all how to make a custom little circuit board, specifically a breakout style board where you have multiple connectors going into or just feeding in other connectors so you can quick disconnect things. Now the main reason I'm doing this is because this particular wiring loom here, if I need to replace any parts, it's a big pain to replace any wiring or replace a particular unit, because I usually have to either do these weird connections and have them zip tied so they don't come apart. And I've had issues of splices and wiring that I've in a particular example, the two fans for the hot end here, the positive lead for these are spliced in through this little connector here. I tried soldering it, but the solder link has failed. So essentially what I need to do, basically make a breakout board between this part of the wiring harness and the various connections like the fans, the thermistor, and the end stop around the back here. Just in case if I need to replace any of those or service them, I can just disconnect them from the breakout board and then reconnect them. Now the position for the circuit board, I think the most optimal place would be right here behind this fan. I have a little bit of an alcove for connections and pins and whatnot. And then of course I also have, it's just the best place, the most real estate, and without taking up any real additional space or causing any issues with it colliding with any other moving parts. So it's pretty well protected. The only thing I do have to account for is I occasionally have to pull this back to pull out filament and run new filament in. So I do need to make sure that the connectors aren't really interfering with my fingers when I do this here, as well as this tube. So there is a little bit of clearancing I have to take into account, and there's also a spinning the gear wheel for this extruder. For what I'm going to do is I'm probably going to eventually reprint this bracket to where it has two additional holes to mount the circuit board, but for now when I do install the circuit board, I'm just going to drill a couple holes and do these little solder nut insert type things. Now before I go ahead and start designing this circuit board, I need to figure out what components I'm going to be using for this particular circuit board, mainly because I need to figure out the package size of each individual component and how they're going to lay out on the board. So that's one of the first things you'll want to figure out, is your bill of materials essentially for the components you want to solder on here. Now there are a couple methods of attaching components to a circuit board. For instance, on this particular circuit board with these diodes, you see that they are SMT or SMD, so they are mounted directly using a solder paste instead of, and then there's also through hole like these connectors here, so which have little pins that you usually have to manually solder onto a board for low production runs. You can't just place them on the board with solder paste like these guys, which I actually do have a toaster oven slash circuit PCB oven for these guys here that I made myself. It's a little bit more involved in the process, and obviously I don't have the parts, the connectors here. Since this is just going to be a simple breakout board, all I'm going to be doing is having connectors like this, these little female type JST XH connectors, as well as a couple of DuPont style connectors. So I've got a couple of 2-pin and 3-pin style JST connectors. I don't have the female ones with me right now. They're somewhere up in my attic. I have to fish them out for when I get these boards ready to rock. These are the type of connectors that will attach the end stop as well as the thermistor to my breakout board. And then the rest of the connections will be handled by these DuPont side angle connectors. So I'm going to use those two type of connectors, and that'll be the basis for it. I'm not going to do any filter caps or anything fancy like that, or any LEDs. Just going to keep it simple and make a simple breakout board. So let's go ahead and cut on over to Fusion 360. I'm going to show you the end product, and then we'll get into it. All right, so we are in Fusion 360 now, and this is the hot end design file right here. And this is the circuit board that I have made a couple days ago. And I started out with Fusion 360, and then I went into Autodesk Eagle and made the circuit board design with the wiring and everything else. So what we have here is we have a main connector header, which is just 7 pins, and then we have an end stop connector. Now that is of course that JST XH connector. I'll put it up on the screen. They don't really represent properly in the 3D view here. And then the thermistor, which is another one, which is a 2-pin. The in-stop is a 3-pin. And then we have more angled connectors for the cooling and the extruding fans. And as you can see, these angled headers are at the back of the board, so they're nice and tucked away and hidden. They're not really in the way of this mechanical bit here where I have the actual where I feed in the filament. So of course there's a lot of unused board space, but the reason I wanted to have the board's contour down here is quite simply because I wanted the board to make contact with this edge, just to make it so if you unplug or plug anything in, there's these two tabs both on the side as well as the bottom aren't going to be the only points where it's holding that load, where in case of, you know, it gets sheared off or what have you. So this is where these screw mounts will go. They're just kind of little tabs that I left out. Like I said, a pretty simple design, nothing too complicated here, very few traces, a lot of it's just direct stuff. And there are a few split traces. For instance, like I said, there is a shared contact for the actual the extruder fan. The ground shares the same ground with the end stop, and then its positive shares the same contact as the cooling fan. And the cooling fan, of course, has its own negative because that's controlled by PWM by the printer board itself. So that just goes off and snakes over to the contact points here. So it's 7 in, and then of course there is 9 out. So just a pretty simple design here. So the first thing I want to do to get this design is I'm going to go ahead and make that guy invisible here. So I'm going to go ahead and create my sketch. So what we'll do is we have our side profile here. Now I'm going to go ahead and click on the face that I want to make the sketch based off of, which is this guy right here. And then I want to go ahead and create a sketch on that face. I'm going to start with a basic line shape. So just going to have a little curved edge right here, 90 degree. And then we'll fix up the dimensions here in a bit. Zoom in a bit, there we go. So I'm just banging out a little quick design. Okay, so we have our basic shape. So essentially we want to go ahead and constrain it to where it won't interfere with any other parts in the model. For instance, I have this conflict right here, which a screw thread may be poking out the other side here. I definitely want to separate that a bit. I believe I had a good separation distance of about, oh no, it was 4. Okay, so I had 4, and these tabs right here are going to be about 8 millimeter in mat. Now it may look like it's conflicting with this this actual heatsink here, which is what this part is, but it is not. The only thing I need to watch out for is this wheel, and then of course try to keep any components away from this general area here. So just going to do the same with the other side, make it 8, and then a good 4 from that. Actually, I think that'll be the minimum measurement for that. So just going off memory of my other design here. Okay, so, oh, come on. There you go. 0.6, and I want to make that a tangent. There we go. And then I want to go ahead and make these two concentric. So I'm going to click that, then that. There we go. That's nice and hugs that contour nice and good. And then I want to make this finger, I think 8. Let's see. Oh, I know what I did. So, yeah, just a solid 8 right there, just to make things nice and consistent. There we go, already picking out issues with my previous design here. Now, obviously I want to make the circle on this pretty much line up with the other one here. And I'm going to make it a little bigger. I think that was 10. Okay, yeah, there we go. So we have our basic design. Just need another hole real quick. And I wouldn't say this is like a particularly like solid CAD tutorial. I'm just trying to bang this out real quick just to show you all the basic setup here. So as you can see, I have that nice contour line just to hug the side of this profile here, and then I have our 2 screw holes set up. I went ahead and did a 3.2 just because that's a pretty typical drill size for circuit boards. 3 is a little bit small. You don't want to make it so your screw is like super tight where you have to bore it out, because if you're doing a high volume run of this, you don't really want to have to drill through too much stuff when the whatever PCB shop you're having this fab through is going to do it for you. So now we have our sketch. So what you want to go ahead and do is click on these 2 profiles here. Now if you have Fusion 360 and Eagle both installed, you can sync between the 2. So it's a really awesome feature. So what I'm going to do here real quick, so I'm going to go ahead and select these 2 here, and then there's an option to go to create. Go down to create PCB, then click on create. Then there we go. We'll keep the thickness. That's usually the thickness for most circuit boards is 1.6 millimeter. You can go thinner or you can go thicker, but that's the average thickness for most boards, and especially for like the budget options like JLPCB and Oshpark and a few other places that you can go to get circuit board. That's like the average run-of-the-mill size. So I'm just going to go ahead and go with that. Doesn't really matter for this particular instance. This is just more of like a simulation showing us the fitment. So as you can see, it clears everything. I had like a few other ways I had this design initially before I factored in the rest of the different parts. For instance, with the previous design, I had those angled connectors in the back. I had them in the front initially. Then I accidentally flipped them around one time while going between Eagle and Fusion, and just saw them in Fusion flip to the other side, and I was like, oh, okay, that works. That's really easy. You can see the naming and all that. It's pretty, you can see all these little diagrams super well, so that works out perfectly. So we have our circuit board design, and I'm just going to go ahead and name this, let's see here, interface. So we have our board design in Fusion 360. So all we need to do is go ahead and save this. Now we can go ahead and open up Eagle real quick, and we're going to go ahead and start a project. We don't have any projects, so we'll want to go ahead and do File, New Project, and this is going to be, I'm not going to call it board, just interface breakout. That'll be perfectly fine. All right, so we have our project. Now what we want to go ahead and do is we want to create a schematic and a board. So I'm going to start with our schematic, and then we'll go ahead and add in a board as well. Yes. All right. So the board, that'll be our second step of this process here. But first, let's go ahead and focus on the schematic. Now, the first step in getting the schematic ready is we want to go ahead and make sure we have all of our parts in here. So for instance, I have 2 different types of connectors. We have the DuPont, and then we also have JST XH 2.54 millimeter pitch. So you always want to get the exact details. I think, okay, yeah, this is the exact kit. Pretty sure this is the exact kit I got. Well, at least I got another brand, but very, very similar. So essentially we have our 2 pieces here. So we're looking at the XH 2-pin and 3-pin males, or yeah, I guess that'd be male. That's kind of weird. You'd think it'd be flipped around, those would be females, but yeah, just right at the top there, those 2 are going to be our connectors we're going to use for that. And then we have our DuPont connectors. For the DuPont connectors, there's a library called Pinhead, which we'll want to import. Now, I already have these libraries downloaded, but all you need to do is just go onto Google and type in whatever your part name you need, and then Eagle library. And it's usually a .lbr file, and there's a few other different formats as well. So what we want to do here is we want to go and add part. That'll bring up our multiple parts here. Now, I know for a fact that my parts aren't in the existing libraries that are already set up here, so I'll have to go ahead and search for them. Now, some of them you can search through the available here. Let's see here. I'm trying to okay, so of course neither of our libraries are here, so I'm just gonna have to go ahead and find them here. So we'll go ahead and get the Pinhead library added in. And then my JST XH connectors. I'll try to find the links for these and put them in the description, but they should be pretty simple to install there. Now, the one thing is you'll want to make sure that they some library sites will specify if there are there's the schematic diagram as well as the actual board circuit diagram. So there's one view for the board as well, or the board view as well as the schematic view. So you want both. Some libraries don't come with both, so you'll just want to watch out for that. We have our libraries. So now we'll need to go ahead and activate them. So there's our pen head, and we'll go ahead and hit use. And then we'll want to go to JST. So there it is, use. All right, so now we have our libraries added in, and we can search by JST now. And that will give us our connectors here. So we'll need the 2-pin and the 3-pin. And as you can see, there are different choices. The footprint is exactly the same. As you can see, there's a little the actual gray portion is the silk screen, so that's like the label as well as the name and value. And then of course you have these two little pads here. So there's a round pad and a long pad. If you are new to making or soldering and you aren't like super duper experienced, I highly recommend going with the long pad, because if you mess up, the bigger the pad, the less of a chance you're going to have of lifting the pad off the board if, say, you have to extract the solder to make, bump my cup here. But yeah, if you have to, say, like extract the solder off of the actual board in order to just make a correction, say if you made a mistake and you just need to suck out the solder to extract the part, maybe it's lopsided or what have you, you're going to have less of a chance of lifting the pad off of the board if it's a bigger pad. So I'd highly recommend going with a long pad, which I'm going to go ahead and do that. Just, I make mistakes too, and with these through hole things, you just can't really go wrong with that. And I'd much rather have much more room for error in case if I do make it, because I'm only human. So I'm going to place one of these here because we need one, and then we're going to go back to our parts manager. And then we're going to go ahead and add in a 3-1 as well. Now, it doesn't matter the order of everything here. You essentially just need to organize everything to where the schematic is A, clean, and B, it's going to essentially be just easy for you to decipher and figure out what's going on with it here. So I'm not going to go into all of the optimizations of how to make a schematic. I'm actually going to link another video. It's by this gentleman named Jeremy Blum. He has a really good tutorial on Eagle. I'm just going to go over the basics for making this breakout board. So I highly recommend watching his video if you want a more in-depth view in this particular software. I'm going to go ahead and go and search for the pinhead library. You got to scroll down here. There we go. So we need a couple of 2, get our angled connector here. These 3 views here, at least these 2 are the required views to make everything work properly. So this is our schematic view, that's our board layout view, and this is a 3D view, which Fusion 360 uses. It's not necessary. These JST connectors don't have it, but these guys do. So I'm gonna go ahead and add these guys in, and I'm just gonna get a couple here. There we go. So we just need one for each fan. And then we're going to add another part. We're going to go all the way to the 7-pin, add that bad boy, the angled connector, just to make it look cool in Fusion 360. So there we go. In order to flip these guys on the other side for Fusion 360's purpose at least, I'm going to go ahead and click on this mirror tool up here. Click on these guys, flip them around. Go ahead and go to the rotate tool and rotate these 2 guys around. Now, one thing with this program is it's really finicky when it comes to where you click on things. As you see, there's like a little bitty crosshair down here in red. You'll want to click on that in order to rotate it. If you click anywhere else, you're just going to get a binging noise, and it's just going to annoy the heck out of you. What I want to go ahead and do now is start labeling some of these connectors, because JP3, JST, all this stuff, it is not going to help us when we go to design the board and route all our connections. So I'm going to go ahead and rename this. Now, typically, you can go to name and value. For some weird reason, these guys don't always want to cooperate. That one does, but best way to do this is to right click and then go to properties. And then we have our values and attributes here. Now the one you want to manage or change is this one here. I'm just going to change it to main. And then I'm going to change this one to cool fan. So we have the cooling fan, and then we have, that'll be short for extruder fan, and then we have these guys here. So that one is going to be our thermistor. So I'm just going to thermistor or therm, and this one's going to be in stop. That one's a little longer, so I can make the name a little longer. Okay, so we have everything labeled here. Now, I don't really have any the polarities or what have you named, but I'm going to make this bottom one a ground. So I'm going to go ahead and move this, make this a little cleaner. Now, these guys, I don't know what it is, but only one particular part moves at once. And to keep it this nice and clean, I'm going to use this group tool up here on the left-hand side to click and drag and select everything in that group. And then, actually, I think you need to still keep it in the group tool in order to move it. So I want to keep these guys connected to these joints up here. Oh, and I'm going to move the in stop first, actually, just to keep things so they aren't knocking into each other. Okay. And really with the schematic view, the name of the game is just organization, the keeping everything nice and organized. And these guys are a little easier to move just because they all move in one group. So I'm going to keep everything, this cooling fan, I'm going to keep like that. I'm going to keep this here. Actually, I'm going to rotate this. Doesn't really matter what orientation it's rotated in the schematic view because that won't really reflect in the board view. This is just to keep everything nice and optimized here. Now what we want to go ahead and do is use the net tool once we have everything moved to where we need it. Basically, you're just clicking from contact to contact. And you can also click an open space once you've clicked from one contact to make just a wire dead end if you need to do that. And then, so something like this. There we go. All right. So that'll be our negative lead going into number 2. So we'll just keep that in mind. Actually, let me move you a little closer here. There we go. Kind of annoying finding that out. Oh, there we go. Okay. So I'm going to try to keep this consistent with being, doesn't really matter which one. So that'll be our negative for that. And then, of course, we'll link in our positive too. All right. So now we'll want to create a splice between our end stop. This will be our ground. So that's going to go to our number 2 contact. There we go. Ah, there we go. Okay. Keep this cleaned up. Move our text. Rotate our text. So this will be our positive, which will splice into the cools positive. So there we go. Okay, so we have our simple schematic. Now there's one more thing I want to do, which is I want to go ahead and add a ground to this. So these two will be connected with the ground plane. Now the reason you want to do this is we're basically going to create a ground plane throughout the entire board. So I want to go ahead and go back to our adding a part list. And then we'll want to go ahead and search ground or GND. And we will want this guy. We can use the other one as well. It doesn't really matter, but that will work. And we're just going to splice it right in there. Yes, there we go. So that will be our ground line there. Now we could also make this one 12 volts if we wanted to. It doesn't really matter. The main thing is I just want to make sure we have a universal ground plane for this particular pin setup here in the in-stop. Now the main reason I can't share the in-stop voltage because there's a positive, there's a signal and a ground. The in-stop is 5 volts and these fans are 12 volts. So I can't share one between the two there. They have to be separate. So obviously I'll need that third wire. Now I could probably just use like a ground and a signal, like 2 wires for the end stop. That'd be okay, but I like to have the LED in there, the extra signal for the LED, just for diagnostic purposes. It makes things a lot easier, so you don't have to rely on like a computer or anything to tell you if the 3D printer is hitting its end stop. So there we go. We have our basic schematic taken care of here. In the next video, we're gonna go ahead and do the board layout, which that's a whole nother ballpark. That's gonna be a bit of a long, involved, and thought out process. So stay tuned for that video. I just want to thank you all for watching. If you like this video, go ahead and hit the like button, consider subscribing, and have a great day.